Unlocking a hidden level of computer performance often feels like discovering a secret cheat code for the internet. Most internet slowdowns have absolutely nothing to do with data providers or aging processors, because Chrome deliberately restricts hardware capabilities by default. Deep beneath the standard settings menu lies a laboratory of experimental switches known as flags that fundamentally alter how data flows through a machine. Activating these hidden toggles can accelerate browsing speeds by up to 200%. So, staying until the very end reveals a sequence of configurations that transforms a sluggish browser into a blistering powerhouse. Flipping the very first switch completely redefines how your monitor handles visual processing. Web pages are written in raw code, and Chrome has to manually translate those text files into actual pixels that display on your monitor, a complex process called rasterization. Standard configurations usually dump this heavy lifting right onto your main processor, which easily clogs up your system when opening media-heavy websites. Activating GPU rasterization completely shifts this massive workload away from your main processor and forces your dedicated graphics card to paint the screen instead. Graphics cards are custom-built to handle complex visual data, meaning they can draw pixels exponentially faster than a traditional processor ever could. The difference becomes immediately obvious when scrolling through image-heavy storefronts, social media feeds, or complex news sites that used to stutter. Suddenly, pages feel incredibly light, and your computer stays completely silent instead of spinning up the fans. Flipping this toggle sets a fantastic baseline for performance, but another hidden setting right next to it makes the memory pipelines even faster. Standard browsing forces your system to play a frustrating game of telephone with visual data, writing image files to a temporary memory buffer before shipping them off to the graphics card. This extra step creates a subtle but noticeable delay, especially when handling high-resolution images or dense web layouts. Enabling zero-copy Rasterizer forces Chrome to write that pixel data directly into the graphics card memory from the very start, completely bypassing the middleman buffer. Eliminating this unnecessary step reduces memory bandwidth usage drastically, while simultaneously lowering the overall strain on your main processor. Laptop users will notice a massive benefit here, as reducing memory transfers directly translates to better battery life and less heat. Websites with massive photo galleries or endless scrolling feeds load with a snappy responsiveness that feels incredibly satisfying. Saving all that processing power sets up the perfect opportunity to boost how Chrome handles online games and interactive visuals. Web-based games, interactive charts, and digital design platforms often crawl to a painful stutter because Chrome tries to render complex 2D animations using software emulation. This software-based rendering quickly bottlenecks your system, dropping frame rates into the single digits during intense visual sequences. Switching on Accelerated 2D Canvas allows Chrome to tap directly into hardware acceleration to process these intricate 2D shapes and fluid movements. Instead of relying on a slow software layer, web applications instantly gain direct access to raw hardware power, resulting in dramatically higher frame rates. Online design tools feel as responsive as expensive desktop applications, and browser-based games run beautifully without a single hiccup. Skimming through interactive data dashboards becomes a breeze, providing a level of fluid motion that completely changes how you interact with modern web layouts. While these graphical upgrades make the interface look amazing, accelerating your actual download speeds requires changing how Chrome handles incoming files. Standard configurations pull files down from the internet in a single continuous stream, which works fine for tiny documents, but causes massive slowdowns on larger downloads. If that single data pipeline hits any congestion or network instability, your download speed plummets to an agonizing crawl. Activating parallel downloading completely rewires this process, allowing Chrome to split your target file into multiple smaller packets and pull them down simultaneously through separate pipelines. Think of it like opening several highway lanes instead of forcing all traffic through a single toll booth. This simple shift drastically shortens download times, allowing you to maximize the full bandwidth of your internet connection. Large videos, heavy archives, and software installers finish downloading in a fraction of the time usually required. Once your files are flying onto your hard drive, the next step is speeding up how quickly Chrome establishes secure connections to websites. Every single time a browser attempts to open a website, a tedious back-and-forth communication ritual happens behind the scenes to establish a secure connection. This traditional protocol requires multiple data trips just to say hello and verify security, which introduces a painful delay before any actual content appears on your screen. Enabling the Experimental QUIC Protocol replaces this outdated process with Google's next-generation connection design, combining connection setups and security handshakes into a single, instant step. Reducing these data trips results in noticeably faster initial page load response times, making the internet feel incredibly punchy. The performance jump feels especially massive when browsing on unstable public Wi-Fi networks or weak cellular data connections, where traditional handshakes constantly drop. Web pages start appearing the exact millisecond you hit enter, eliminating that awkward pause where nothing happens. Making the connection instant is wonderful, but ensuring the page glides smoothly under your fingers requires fixing the way scrolling feels. Standard scrolling across long articles often feels incredibly jarring, moving down the page in a choppy, tick-by-tick motion that strains the eyes. This visual lag makes skimming dense text incredibly frustrating, as the content constantly jumps around instead of gliding naturally. Toggling smooth scrolling replaces that primitive animation with a fluid, continuous motion that responds beautifully to your inputs. While this specific change does not technically alter how fast raw data downloads, the psychological impact makes your entire browsing experience feel infinitely faster and more responsive. Reading through lengthy documentation, endless social media feeds, or massive text files becomes a genuinely pleasant experience free of visual stutter. Your eyes can easily track words as they move across the screen, eliminating the disorientation caused by default page jumps. Once your text flows like water, it's time to look at how Chrome processes heavy online media streams without choking. Streaming high-definition video from platforms like YouTube or Twitch puts an immense strain on your machine, requiring constant decoding of massive data streams. Left on default settings, Chrome often burns raw processor cycles to decode these videos, which causes background tabs to freeze and makes your computer run hot. Turning on hardware-accelerated video decode forces Chrome to offload this heavy lifting to your computer's dedicated hardware video decoder. Utilizing this specialized hardware ensures silky smooth 4K video playback with zero dropped frames, even if you have dozens of other tabs open in the background. Your laptop will run significantly cooler, and you can say goodbye to those annoying lag spikes that happen when a video starts playing. Background tasks keep running at full speed, letting you listen to high-quality streams while tackling intense workloads without a single stutter. To ensure these script optimizations translate perfectly to your screen, matching Chrome to your specific operating system is the final piece of the puzzle. Chrome ships with a default graphics backend designed to work decently across a wide variety of hardware, but this middle-of-the-road approach often causes micro-stutters. Leaving this setting on default means your browser might not be communicating effectively with the specific graphics architecture inside your computer. Manually adjusting the Choose Angle Graphics backend allows you to select the native graphics language of your operating system, such as Direct3D 11 for Windows or Metal for Mac. Selecting your native system language eliminates translation layers, completely wiping out the micro-stutters and choppy scrolling that plague video platforms and complex web layouts. Web pages render with absolute precision, and the entire interface gains a level of snappiness that default settings simply cannot replicate. Matching Chrome directly to your hardware components unlocks the absolute maximum potential of your machine, giving you a lightning-fast browsing experience that feels custom-tailored. Unlocking hidden potential inside Chrome does not require buying an expensive new computer or paying for premium upgrades. Flipping these hidden toggles completely transforms your daily browsing, replacing frustrating loading delays and choppy scrolling with a blazing fast, responsive experience. Suddenly, heavy web applications feel incredibly light, large files download in record time, and high-definition video streams play beautifully without causing your machine to overheat. Drop a comment below sharing which specific toggle gave your machine the biggest performance boost, and give this a like if these speed increases helped save your sanity. Subscribe to catch more deep dive performance guides and enjoy your newly supercharged lightning fast browser.